Greetings, fellow seekers of symmetry, motion, and mathematical truth. Welcome to Advanced Tech World, where the constants of curiosity meet the variables of discovery. Today, we step into a fascinating moment in scientific history, an era where intellect clashed with ego and equations became weapons in an invisible war. This isn't just about math, it's about power, pride, and the very birth of modern physics. Get ready to explore the untold story behind the secret war of calculus. In the late 17th century, two of the greatest minds in human history found themselves entangled in a silent war, not of armies, but of intellect. This was no ordinary dispute. It was a battle over the ownership of one of the most powerful tools ever conceived by humankind, calculus. The story of Isaac Newton and Gottfried Wilhelm Leibniz is a saga of genius, secrecy, pride, and national rivalry. It is a tale where discovery and ego collided, shaping the very foundation of modern science. Welcome to Advanced Tech World, where today we uncover the untold story behind the secret war of calculus. Isaac Newton, the reclusive English mathematician and physicist, began his work on what he called the method of fluxions around 1666. During the same years, he discovered the laws of motion and gravity. He imagined variables flowing over time, changing continuously like rivers, hence fluxions. But Newton was cautious, even secretive. He rarely published his methods, choosing to guard his ideas, fearing criticism and controversy. Across Europe, another genius was rising, Gottfried Wilhelm Leibniz, a German philosopher, linguist, and mathematician, who approached mathematics from a more symbolic and logical angle. By the early 1670s, he was developing his own approach to describing motion and change. His great leap came in 1684, when he published his paper on differentials, the foundation of calculus as we know it today. At first, both men appeared unaware of each other's progress, but as Europe's scientific community began to correspond through letters and societies, whispers began to spread. Leibniz had seen some of Newton's unpublished notes, which had circulated among scholars in England. Was it coincidence that both arrived at the same mathematical breakthrough, or had one borrowed from the other? By 1699, these whispers became accusations. Nicolas Fatio de Duillier, a close ally of Newton, publicly accused Leibniz of plagiarism. What began as a scientific discussion quickly escalated into a bitter international feud. The Royal Society of London, the most powerful scientific body of its time, launched an official investigation. But the investigation was hardly impartial. Newton himself, as president of the Royal Society, oversaw the inquiry. The resulting report, known as the Commercium Epistolicum, declared Newton the true inventor of calculus and implied that Leibniz had copied his ideas. But many saw the verdict as deeply biased. Leibniz, humiliated and heartbroken, defended his independence until his death in 1716. He maintained that he had developed calculus on his own, unaware of Newton's fluxions. To this day, historians continue to debate the truth, but most agree both men made their discoveries independently. The fallout from this feud split the scientific world. Britain remained loyal to Newton's notation, using dots and geometric language, while the rest of Europe embraced Leibniz's simpler, more symbolic form, dy dx, and the elegant integral sign, integral. Over time, Leibniz's notation proved more flexible, intuitive, and universal. His system became the foundation of modern mathematics, physics, and engineering. Newton's fluxions, though brilliant, faded from use. The battle for credit may have been bitter, but the world ultimately benefited from both men's genius. Yet beneath the equations lay something far deeper, a clash of worldviews. Newton saw the universe as a machine governed by divine laws, and calculus was his tool to describe that cosmic order. Leibniz saw it as a web of logical relationships, where symbols could unlock the secrets of existence. Their conflict was not only about invention, but philosophy itself. Reason versus revelation, logic versus geometry, secrecy versus communication. More than 3 centuries later, the echoes of their rivalry still shape science. Every time an engineer calculates acceleration, every time a physicist models the motion of planets, every time a programmer simulates motion in artificial intelligence, they are using the mathematical language born from this intellectual war. Calculus didn't belong to one man. It was the result of a civilization ready to measure motion, to understand infinity, to grasp the flow of time itself. So, who really invented calculus?